how many possible ways, how many different combinations of 3 different book titles can you make out of 18 books? So it's saying something like, say you have 3 books, right? You have 5 books, okay, say you have 5 books, 1, 2, 3, 4, 5, right? And you need to choose two selections, right? You need to make 2 choices. Okay, let me sort in the problem down. Say you have 5 books, right? And you need to make 2 choices. So how many possibilities are there, right? So you know, you have to find how many different choices you can make without repetition, okay? So what are the combinations you can use? Like you can say, so say this is 1, 2, 3, 4, 5. So say, you can choose 1 and 2. You can choose 1 and 3. You can choose 1 and 4, 1 and 5, right? This is how you choose, but the way you calculate is different. The way you calculate is how many books are there? 5, right? The first one you have 5 books. The second one you have 4 books. So that's going to be 20 different choices, right? But when you do it, you'll see it in here. So one can go with 1, 2, 1, 3, 1, 4, 1, 5. It can be 1, 1. 1, 1 it cannot be because you'd have a without repetition. You can't repeat it, right?
Yeah.
So you can have 2, 1, 2, 3. You can have 2, 2, 2, 4, 2, 5. So this is 4, right? This is 4. So for 3 it's going to be 4. And for 4 it's going to be 4. And for 5 it's going to be 4. So the total will be 4, 4, 8, 4, 12, 16, 20. Right? But we did it in shortcut. We just multiplied it and we got the answer. Because for like a lot, like even for 5 books you have to do all these combinations. For 18 books you have to do a whole different combinations. Right? So you just multiply it and you get the answer.
Okay. Now that was problem 12. Okay. Now we're going to roll down to problem 13.
What is 13?
13 is find the mean of the given probability distribution. The random variable is X.
A number of houses sold by a realtor in single month. Okay, this probability distribution is follows. You have XPX, find the mean. So to find the mean, you have to find the, okay, XPX over N, I guess. XPX plus, yeah, I think it's this. I have to take, so XPX, tell me what X and what PX are. What are X?
My X is 0, 1, 2, 3, 4, 5, 6, and 7. My PX is 0.24. 0.1, 0.12, 0.16, 0.01, 0.14, 0.11, 0.21.
Okay. So you have to do X times sum of X times PX. That's your, what is it asking?
It's asking you find the random variable X. What is the single one?
Find the mean of the given. It's asking you to find the mean, right?
Yeah.
So the mean is going to be X times PX. Sum of X times PX. So what you do is you multiply this to this and then add them together. So 0 times 0.24 plus 1 times 0.1 plus 2 times 0.12 plus 3 times 0.16 plus 4 times 0.01 plus 5 times 0.14 plus 6 times 0.11 plus 7 times 0.21. Is the last one 1?
0.21.
Yeah, so 3 point, I think 0, 1, 2, 3, 4, 7, 21, 6, 11, 5, 14, 4.01, 3.16, 4.3, so 2.1 to 1.0, 1 is 0.01, okay. I see what was wrong. So 1 was 0.01. Okay, 3.6.
1 was 0.01. Right? So you just multiply it and then add. So what you do is 0. So your x, first x is what? 0 times 0.24, right?
Yeah, it's going to be 0.
0.24 plus your second one is, yeah, that's going to be 0. 1 times 0.01. 1 times 0.01. The third one is 2 times 0.12. Plus your fourth one, third, this is 3 times 0.16. So you do it all the way till this. 7 times 0.21. And the answer would be, you have to note it down on your paper, because note it down on your paper too. Because it's going to be, it's 3.6. The answer.
3.60?
Yeah, it's the same thing.
Okay. We're going to start on 14. That was 13.
It was 30.
14 is determine whether the given procedures results in a binomial distribution. If not, state the reason why.
Okay, so it says rolling a single die 19 times.
I'm going to get a phone tomorrow, so just send it to my phone.
I'll try to send it to you.
I'm going to get a better phone tomorrow.
Keep the track of numbers that are rolled. Keeping the track of numbers that are rolled.
Tracks of numbers that are rolled, right? So it asks you to find if it is binomial distribution. Is it binomial distribution, right? So it's asking this thing. You know what binomial means? Binomial means two. So if you it only works for cases that have
I might get one today.
2 outcomes. How many outcomes does this have? Rolling a die, how many outcomes does this have?
It has 19.
No.
18.
No, rolling a die, like how many outcomes does the die have? The 6-faced die.
Well, it has 6 sides.
6 sides, right?
Yeah.
So it has to have just 2 outcomes, but that one has 6, right? So that's why it's not a binomial distribution. So this is not a binomial distribution. So it says there,
Not binomial, the trials are not independent. Procedures results in binomial, not binomial, there are too many trials. There are more than 2 outcomes for each trial. See? There are more than 2 outcomes for each trial. That's why it's not the binomial distribution. Because it has 6, right? So, assume that the procedure yields a binomial distribution in trial repeated n times. We use the binomial probability to find the probability x. Okay. So you've given x, n, x, and p. Okay. Tell me what are the values for n, x, and p.
Okay, basically n is 12.
Just give me 1 second. I have to run this. 15. N is 12.
X is 5.
X is 5.
And P is 0.25.
Right?
Yep.
So the formula for binomial distribution xn times p to the power of x q to the power of n minus x. Right? Do you remember this formula?
Yeah. Oh man, I remember that formula. I worked on it so much that I.
So 5, 12, p is what? 0.25. What is q?
Q is 1 minus 0.25. Wait. Where's my calculator?
It's right here. 1 minus 0.25 to the power. What is n minus x? 12 minus 5 is 7. Okay. So how do you do this? What formula you use for this? What is the formula?
It's a division. You divide 5 over.
5 minus 12, no. It's 5 factorial over 7 factorial times.
You sure?
Yeah. N factorial over n minus x times x factorial. So it's 12 factorial. 12 factorial over 7 factorial times 5 factorial. And this 7 is because this is 12 minus 5 factorial. See, this is n factorial over n minus x factorial times x factorial. And then the rest is same. So what is this value? This is going to be 12 factorial over 7 factorial. So that here. You don't have a, do you have, yeah, you have 12 factorial over 7 factorial times 5 factorial. And this is 792 times 792 times 0.25 to the power 5 times 0.75 to the power 7. This is equal to 0.1032. So what's the answer? Is it there on this? On the answer? 0.10?
Mm-hmm.
1032? It's there on the answer?
Right there.
Yeah. G is a standard, find the probability G is less than 0.97.
Okay. 15, 16.
Do you smell the heater?
Yeah.
Okay. Just have to make sure I wasn't only you smell of that.
So it asks you to find probability greater than what?
0.97.
X is greater than 0.97, right? Is it greater or smaller?
It is greater.
Greater, okay. So tell me.
No,
what
it's
it is.
it's smaller.
Smaller? Okay, you should know this. He says this is a normal distribution.
So if I go to the z-score, I'm gonna find it.
Yeah, but what is your G?
My z is 0.97.
So find it.
All right, hold on. Let me go to the table. I'm gonna use a bell curve.
It's there on the table. The table, yeah.
So basically, what we're gonna do here, 0.97. So I go to my answer is 0.8340. 0.8340.
Let's move to number 17.
0.8340. Whoa.
Yeah.
Okay. Now we're going to 17. Assume that X has a normal distribution and find the indicated probability.
It says
The mean is Q equals 15.2,
15.2.
and the standard deviation is sigma equals 0.9. Find the probability that X is greater than.
Find the probability X is greater than 1, 15.2.
Okay, now it says probability of X greater than 0.92. What is it? 15.2, okay. Okay, you know the difference between, you notice the difference between these two?
Well, the one at the top, you would have to use the z-score. The one at for 16, you would have to use the z-score.
For 17?
You would probably have to use the t-score or the critical.
Yeah, you have to find the z-score on this thing.
So for 17, I would have to